Cool. So this would have 6 letters. I would have R-E-G-I-N-A. And then I box the A, let's say. Then it would be 5. Then it would be 4, which is 120. Suppose a word is any string of letters. How many 5-letter words can you make from Kelowna? So this would have 7 then, which is then we have this one. How many numbers are there from 1,000 to 1,999 that do not have repeated digits? So this could be a 1. That's the only option it has in order to fall between 1,000 and 1,999, right? So the only option I have is a 1. I'm not allowed to repeat, so I'm going to box and hold it. And then I have 1 there. Then this could be 0 and then 2 to 9, which is 9 options. Hold the 0, 2 to 9, which is 8. Hold the 2, 3 to 9, which is 7. When you do 9 times 8 times 7, what do you get? 504. We have to start with a 1, because if we start with any other digit, it's 2,000 or 3,000 or 4,000 or 5,000, and I need it to be 1,000, right? The next one says, how many ways can you rearrange Pocky if the first and last letters must be consonants? So this is a consonant, 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 and then these are vowels. So 1, 2, 3, 4, 5. The first and last letters must be consonants. So I have P, C, K. But it's gravel tiles, so I have to box and hold them, correct? So say I hold the P. Then I have CK, which is 2. Pretend I hold the C. Is there any restrictions on those middle blanks? They can be the leftover letters. How many leftover letters are there? 3. There's the K, the O, and the E. So 3, say I hold the K. Then I have O and E, which is 2. Hold the O. Then I would have E, which is 1. So it's 36. Then this one says, how many odd? 3-digit. Odd means it has to end in an odd number. 3-digit means it can't start with a 0, right? And it can be repeated. So I have 1, 3, 5, 7, or 9 for the back blank. So that's 5. And here I would have 1 to 9 because I can't have 0, which is 9 blanks. 9 digits, sorry. And then here I could have anything, 0 to 9, which is 10. So it would be 450. I still have to deal with restrictions first always. So for this one, I can't have repeating digits. So I still have to start at the back, which is 1, 3, 5, 7, 9, because it needs to be odd. Which is 5 options. If I can't repeat, it means I have to box and hold something. So it's 1 to 8, which is how many options? 8. Yeah. Hold the 8, and I get 1 to 7. But what do I have to remember? The 0 can come back because I couldn't use it at the back and I couldn't use it at the front. So it would be 8. So it's 64 times 5, which is? Okay, then I'm getting you guys to open your notes back up, please. Go back to your note package I gave you.
Yes.
I do have a little baby. Yes, that's the pages that border at the bottom. All right. So we're on this page. It says, Mr. and Mrs. Wagner, who are my parents, want a family picture taken with their children, Jeremy, Jesse, and Crystal. Jamie got excluded because I had to have an odd number of children, so sorry, brother. In how many different ways can all 5 line up in a straight line for a picture if this is the case? So you're doing these ones. So here there are no restrictions. So we still have all 5 blanks for the people. There's no restrictions, so there's no place I have to start at first, right? So I would have 5 people here. Then can I repeat the same person? Do I have an unlimited amount of people that I can just do 5, 5, 5, 5, 5? No. I have 5 people here, but then I make someone stay there. They're in a line for a picture, right? Then 4, then stand there. 3, then stand there. 2, then stand there. 1. So it's 5 factorial, which I showed you how to type in your calculator yesterday, which is 120. The parents must be at either end. How many parents are there? 2. So it has to be a parent and a parent, correct? I can start at either end. I like starting at the left. So how many parent options do I have here? 2. Then what do I make them do? I make one of them stand there, correct? So how many parents do I have left for this blank? 1. Cool. How many people do I have standing currently? How many people do I have standing? I have 2. How many do I have left? 3. So I have 3 for this spot, then 2, then 1, which is 12. Baby crystal must be in the middle, so we stick crystal here. How many crystals are there in this group? 1. How many people have I stood in place? 1. How many do I have left? 4 for here. Then I make them stand, then 3, then make sure you have multiplication dots. So it's 12. Then this one says the children alternate with the adults.
Isn't that 24?
Yep. For some reason I did this 4 and 3 and then stopped. So we have 5. The children must alternate with the adults. So what do I have to start with, a child or an adult? Child, because there's more of them, correct? So I would have to go child, child, child. So how many children do I have for this blank? 3. Then for this blank? 2. Then for this blank? Now what about adults, adults? How many adults do I have left? 2. Then? And that's 12. Then here it says 3 boys and 3 girls are on a mixed league volleyball team. They want to take a picture of their team for the season where boys and girls alternate. Boys and girls alternate. So that's how many of them are there? 6. If boys and girls alternate, do I start with boys or girls? It doesn't matter. So I actually have 2 cases then, don't I? Envision this as boy, 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 or we can envision it as starting with girls. Would the picture look different? If you looked at the 2 pictures, could you tell them apart? If I started with boys and then the next I started with girls. Yes, you could tell them apart. So you have to have 2 separate cases. This last one, we only needed 1 case because we had to start with children or they wouldn't alternate. This one has an even amount. That one had an odd amount. So here I would have 3 boys, then 2, then 1. Then here I would have 3 girls left, 2, then 1. So this is 36. And then this would be 3, 2, 1, and then 3, 2, 1, which is also 36.
Did you drop in if I like 36 ones?
Nope. That would just mean you understand there's 2 cases that make the same answer.
So for 8C, like I'm just confused how it's 24. To go up. Oh, sorry, how is that 24?
4 times 3 times 2 is 24.
Yeah, but like what about the 5th person? Like why is there 2 ones?
Because this is the child. This is Crystal. She had to get set here first.
Okay.
Then I only have 4 people left for this one.
Okay.
Then 3. Then 2. Then the last person has to go there. Yeah. It's only because that first limited one actually happened before all the rest happened.
Okay.
Yeah. Okay. A permutation is an arrangement of objects in a definite order. So order matters, where each object appears only once in each arrangement. For example, ordering 3 stuffies, a kitten, a puppy, and a bunny. So we're going to call the kitten K, the puppy P, and the bunny B due to my laziness. On a test, I would never be lazy, I would write out all the words, right? So we are going to show all the different ways I can arrange these 3 stuffies for a photo in a line to look in front of you. So they would look different, right? So I could go, bless you, kitten, puppy, bunny, or I could go kitten, what? Bunny, puppy. Or I could go puppy, bunny, kitten. Or I could go puppy, kitten, bunny. Or I could go bunny, kitten, puppy. Or I could go bunny, puppy, kitten. So how many different arrangements do I have of those 3 stuffies?
6.
There are 6. So this gives me 6 different options. We agree? Well, 6 isn't too bad, but what if the answer is 1,024? Are you going to make yourself a table? No, you're probably going to miss 1 or 200 cases. Okay? So what we can do then is we're lining them up. If we're lining them up, if we line something up and we want to see it, we can physically draw the lines as if we're visualizing them standing in front of us. Or we're visualizing them putting them in a line. So what I can do here is this is spot number 1. Then this would be spot number 2. Then this would be spot number 3. In spot number 1, how many options would I have? In spot number 1, how many stuffy options would I have? 3. Now what's the catch here then? I have to leave one of them, correct? I'm trying to line them up. So I can't just have like, if I put 3 and then 3 and then 3, I'm never actually laying a stuffy down to line it up, right? So this one here, I could have a puppy, bunny, and a kitten, but then I pretend to box and hold to leave the kitten behind, right? Then for number 2, what do I have left? 2, the puppy and the bunny. And then I have to leave one behind. Say I leave the bunny. Then I would have the puppy, which is 1, and so I would get 6. So you can actually line them up and see what they look like. So if it says arrangement, it's a permutation where order matters. So like phone numbers, order matters, right? Because if I put it out of order, it doesn't call you, correct? License plates, if I put them out of order, even if I have the same letters and numbers, am I going to get the same car? No, because order matters. Codes to get into your bank account, right? To use your card. If I give you a 4-digit code, but I don't tell you the order, could you put it in any order and it would work? No. So permutations, order matters. So we're over here. We're going to talk about factorial symbols. So what does 6 factorial mean, guys? How else could I write? 6 times 5 times 4. Where do I stop at? 1. Because that's what that means. It's that blast off, right? So that's 720. What about this one? 9 times 8 factorial. That would be the same as 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So how else would I actually write it instead of 9 times 8 and 7 times 9 factorial. This is just 9 factorial. What about 5 factorial over 3 factorial? Well, 5 factorial is just 5 times 4 times 3 times 2 times 1 all over 3 factorial, which is 3 times 2 times 1. Is there anything I could do? Is there anything I could cancel off on the top and the bottom, make it easier so I don't have to type in my calculator? Yeah. 3 and the 2 and the 1. So this is actually equal to, bless you, 20. Then I want you to go to D. I want you, everyone go to your calculator and type in 3 factorial times 4 factorial to practice it. 3 factorial times 4 factorial. 3 factorial, 4 factorial is what? All right, we're bypassing this because it just confuses people. I want you guys to, if I gave you this, we're going to look at this. 43 factorial over 40. If you put it into our calculator, it gets mad at us. Is there any way we can do it so that we don't have to type it in and reduce it ourselves? So we could go 43 times 42 times 41 times 40 times 39 times that to 1, technically, right? It's too big. The number's too big. Now, what about 40? Sometimes it doesn't. It could be like if you put in 100, it won't work. So we're just doing it. What happens if it overloaded your calculator when you do it? Okay? So 40 factorial would be 40 times 39 times ... all the way to 1. Correct? So is there anything I can do? Oh.
Cancel them off like where they started. Like,
Yeah. I can just cancel this 40 all the way to 1 off, and this 40 all the way to 1 off, and then it's just 43 times 42 times 41. So if you type it in all at once, it won't fight you, but if you type 43 factorial in, I'm pretty sure it does. It gave you a big number. So then it's still fine. If you type in 100 factorial, put that in. Like eventually it'll be too big and you'll get mad. Like it'll overload it. So what's 43 times 42 times 41? Sorry, what is it? Maybe just read the numbers first. 46. Thank you. Okay, then we're flipping over. We're not going to do the letter ones. Confuse people. Okay. We're going to learn how. So here, there is the formula on your formula sheet with the NPR. He let you guys keep them, right? You kept the formula sheets for your test? If not, I don't know where they appeared because I don't have them anymore. Some people kept them, some people didn't. Okay, I'll print off more just in case. So, we're learning how to type these in our calculator. So, everyone following along? Explain what it is in a second. I'm going to teach you how to type it into your calculator. So, I want you to go 8P3. So, you're going to go 8. Math, back to probability again. And I'm going to pick NPR. So we're doing 2 because it's a permutation. 8P3. For right now, it doesn't mean anything to you. I'm just teaching you how to type in your calculator. Okay? So 336. 8P3. You go to the same spot as probability as you did for the factorial. 8, math, probability. You pick P, NPR, number 2, and 3. It's 2 above the factorial symbol, guys. 336. So I'm just teaching you how to type in your calculator. You have no idea what this is. Okay? But did everyone get it to go into their calculator? Okay, bless you. So we have 336. Well, what the heck does this mean? It means this. I have 8 numbers to choose from, and I'm picking 3 of them. So how could I represent this with a fundamental counting principle? I'm picking 3 numbers from 8 without repetition. So another way I could look at it is I have an 8-letter word, and I'm making 3-letter words out of it. You know what I mean? I have an 8-letter word, and I'm picking 3-letter words out of it. So how many options would I have for this blank then? 8, then?
7.
Then? So type that into your calculator. Holy smoker doodles, it's the same thing. So, if I had the word Kotham, I just made up a word because I wanted one that I could just went with like, I don't know. Anyways, it works. There's no doubling, tripling letters because we haven't talked about it yet. If cobweb would have been much better. But you know, we're at Cotham. I don't care. So I want 4-letter words. How many 4-letter words can I make from Cotham? Well, you would go boom, 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 boom. 4 blanks. How many letters would I have for this blank?
6,
Then?
5,
Then?
4,
Then? How can I represent this as a P?
6, P, 4.
6P4. The catch in order to use the P is that these have to go down by 1, so you have to have no repetition. If I could go like 6, 6, 6, 6, 6, 6, whatever it may be, or 7, 7, 7, 7, I can't use the P. So I want you to get the answer to 6P5, and I want you to show me how you would do it with the blanks. What's the answer to 6P5? 720. How many blanks would I have if I represent with the fundamental counting principle? 1, 2, 3, 4, 5. So this is the number of blanks. And then this is the total, right? So I start there, I have 6, 5, 4, 3, 2, which is 720. Now with the P formula, if I have NPR, okay, what does N have to be compared to R? Bigger or?
The same.
Or the same. It has to be bigger or the same. That's exactly it. So your N has to be greater than or equal to your R. Now how the heck does that even make sense? Well, if I have 6 objects and I pick 7, does that make sense? No. Can I have 6 objects and pick 6 though? Yeah. Can I have 6 objects and pick 2? Yes. This number just cannot be bigger than that one. That's all. Because you have 6 and you choose 7 doesn't make sense. I have 6 spaces and I'm choosing 7. Well, you can't do that. Right?